So hello everyone. In this part, I will discuss the enhancement type MOSFET. Actually, in the previous part, I discussed the depletion type MOSFET in the very details. Okay. Actually, the depletion type MOSFET it is not used in the di- digital design or amplifier design. Okay. If you have an idea of the MOSFET SE analysis, that is the amplifier design. So in that case, the depletion type MOSFET is not used. Why? The reason behind is in the previous part I told like that in case of the depletion type MOSFET, the output current, this output current is not depend upon the input voltage. Means we are not applying any input voltage and still we are getting the current. That's why we don't use the depletion type MOSFET in amplifier design. You can check here because the output current is not depending completely on the input voltage VGS. Means even we are not applying any input, that is the VGS is 0 volt. I am not applying any voltage at the gate terminal, but still we are getting the current. This current I already explained this thing in the previous video. Okay, that's why we don't use the depletion type MOSFET. So that's why we go for the enhancement type MOSFET. Actually, you everywhere you every where so here like that there is a nmos and the pmos and the pmos is there. So this is the enhancement type MOSFET is there. Actually, enhancement type MOSFET is the two types: n channel and p channel. N channel means that is the nmos, or p channel enhancement type MOSFET means pmos. Okay, so here I will discuss in the very details the construction of the n channel enhancement type MOSFET. It is also called the nmos. Okay, so I am starting with the discussion. So the first point is in case of the in the depletion type MOSFET, I explain one thing. Channel is already exist between the source and drain, but in case of the enhancement type MOSFET, channel is not exist. Channel is not exist. Channel is not exist. So this channel between the source terminal and the drain terminal, channel is not exist physically. We need to create the channel. Okay, this is the completely p type is there. This is the completely p type. How I am telling that like that? So firstly, if anytime if I tell like that the substrate, yeah, body, this all name are the same. Body, yeah, bulk. Okay, this all four name is same. Okay, so firstly, here I will take the p type substrate. Okay, p type substrate, body या bulk you can say. Okay, so mostly I will use the substrate term. So here I took the p type substrate. Inside the p type we dope the highly with n plus region. Okay, and one terminal is the source and other is the drain terminal. Okay, and there is a no channel is there. It is completely the p type, no channel is there. Okay, so you are thinking like that the in depletion type MOSFET, even if we apply the here the positive voltage on the drain terminal, actually we need to attract electron. No, if we apply like the yeah, suppose I am seeing like that. Actually, right now no channel is there. So even we apply the positive voltage and the drain terminal, will not get any current, will not get any current. How I am telling. And suppose this is connected to the ground, this is connected to the ground gate terminal. So here the channel is not for. First step, we need to create the channel by applying the positive voltage on the gate terminal. But right now I didn't create channel. I am telling the answer of one question: why we need to make the channel. Okay, that thing if anyone asks like that, see, if we apply the positive voltage on the drain terminal, then electric field will be set up. Due to this electric field, the electron will attract from the source terminal to the drain terminal. So this is the electron, this is the minus, this is the electron, this is the electron, this is the electron, this is the electron. But so due to this electric field, the electron, so due to this electric field want to like that the attract the electron. But this thing is not possible. Why? Because this is the completely resistive path is there. The p type representation, negative ion, this is the whole, this is the complete negative ion is there, means this is the completely resistive path is there. So if this electric field want to attract the electron, it is not possible. Okay, that's why even if we apply the positive voltage and drain terminal, we will get the zero current. Because of that, the electron are not able to travel from source to drain. Electron are not able to move from source to drain, because there is a resistive path is there, that is not a conductive path. Okay, this thing I am telling. Okay, see, even if we, so VGS, if VGS is the 0 volt, the no benefit is there. Suppose if we apply the VGS is negative. Suppose VGS is, if we apply the VGS is negative volt. So due to this negative voltage, I am changing the color. Due to in this figure, I am, yeah, I am making the this figure I am telling. If we apply the VGS is negative voltage, here the negative, 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 negative. Due to this negative, a electric field will be set up from this direction, from this direction. Due to this electric field, more number of hole will come into the channel. Okay, more number of hole will come the channel. So already, if we apply the VGS 0 volt, channel is non-conductive resistive channel is there, and we apply the negative voltage on the gate terminal. Due to that, channel is more and more is going to be non-conductive, means resistive. So also no benefit is there, and the current will be zero. Okay, so that thing you need to tell, if anyone ask like that, why we need to make the channel. Okay, because of that p-type substrate is already there now, so why we need to make the channel, so that thing we need to explain. So tell like that, see, if we apply the voltage like 0 volt and negative voltage on the gate terminal, no benefit is there. Because of that, channel is not there. Even we are applying the positive voltage on the drain terminal, due to this voltage there is a setup of, there will be set a electric field from drain to source. So due to this electric field, electrons are not able to move from source to drain. Why source to drain? Why? Because of that, there is a resistive path is there. No, resistive path is there. Electron can't move in the resistive path. Okay, this you can tell this is the depletion ion totally. Depletion ion is there, so it can't move. Okay, I think you understand answer of this question. Why we need to make the channel firstly. Okay, if we don't create the channel, even we are applying the 0 volt and negative voltage on the gate terminal, we are getting the zero current. We are getting the zero current, that is the id is equal to 0. This region is also you can call, this is the cutoff region, you can tell. Okay, now I am coming back with the analysis part. Suppose so here, now I will apply the positive voltage on the gate terminal, and firstly I will create the channel. How I am telling here. Okay, suppose this is the our MOSFET is there. Okay, so this is the p-type substrate, I think, and this is the source terminal, and this is the drain terminal. This is the source and this is the drain, and this is the gate terminal. Okay, now how the construction actually, in case of the n-channel enhancement, this is the p-type substrate is there. Okay, now we apply the, now we will apply the positive voltage. So if we apply the positive voltage on the gate terminal, so this is the complete, this is the positive, this is the positive, this is the positive. Due to this positive, and this is the channel is non-conductive in nature. Inside there is a hole, this is the p-type representation is there. Okay, and the minority electron is there. In case of the p-type semiconductor, electron is minority is there. Okay, this is the electron is there. Okay, see, so due to, if we apply the case first, case 1, if we, so VGS will be the greater than 0 volt. VGS we will apply the positive voltage. Here we apply the positive voltage, any magnitude. If we apply the positive voltage on the gate terminal, you know already, to balance the charge, a negative charge will be developed at the surface of the body, means the channel you can say, and a electric field will be set up like that. A electric field will be set up like that. You already know na, on the capacitor. If the one capacitor, if one plate of the capacitor is positive charge and this is the oxide layer, automatically negative side will be generate the negative charge. So this behaves like a MOS capacitor. This is the thing. Okay, I'm not just, you should understand, if we apply the positive voltage here, the negative charge will be developed on the other plate, you know already now. So this is the this layer is the oxide layer. I already told in the first part, this is the metal, and this is the semiconductor. This is the semiconductor, that's why name is the metal oxide semiconductor. And field effect transistor, why I am telling this thing, I will also tell here. Okay, so the electric field is there. Due to this electric field, I know I told already, actually this is the direction of the electric field. So in the opposite direction the electron can move only, and in the direction the hole will move. Okay, hole will move, or this is the electron. So this is the direction of the electric. Due to this electric field, electron will go up, electron will go up into the channel. Okay, and channel start to going into the conductive. Okay, conductive. Now if we again increase the VGS voltage, if we again the VGS increases, then more number of electron will come into the channel, more number of electron will come into the channel, this electron will also will come the channel. And if any one of the hole is there, hole will go the bottom of the substrate. Okay, more number of electron will come. Okay, if this thing is happening, if we increase more and more VGS, the more number of electron will come. At a certain voltage, at a certain voltage of the VGS, the sufficient number of electron will come into the channel. Okay, that voltage is called the threshold voltage, and channel will go inverted. What I am telling, understand? Here I am telling the VTH, that is the threshold voltage. VTH, the threshold voltage. Sorry, the threshold voltage. Because of that, if we applying the if we are increasing the positive voltage on the gate terminal, at a certain value of the voltage at a gate terminal, sufficient number of charge carrier will come to the channel, and channel start to invert. So this is the threshold. I think threshold voltage. Okay, this is the threshold voltage. So what I am telling, the definition of the threshold voltage, at a at a value of VGS, at a value of VGS, at a value of VGS at which channel inverted, channel inverted, channel inverted, that voltage is, that voltage is the threshold voltage. Okay, see, if we apply the voltage on the gate terminal at a certain value of the VGS, at a certain value, actually the source and body always the short circuit. I know that thing. Source and body is always short circuited. I think you already know this thing. Okay, so if we apply the positive voltage and more voltage, we are increasing the VGS at a certain voltage, the channel has inverted and sufficient number of electron will come to the channel, and this concentration of electron, is equal to the majority charge carrier in the bulk of the substrate, in the bulk. So actually in the p type semiconductor, majority charge carrier concentration is p type now. So the channel is inverted, means the more and more electron will come into the channel, and this electron is equal to the majority charge carrier of the p type semiconductor. Okay, that thing I am telling. Okay, means at the threshold voltage, the sufficient number of electron will come into the channel, and channel start going to be the conductive. Okay, that voltage is called the threshold voltage. If we apply the further voltage, VGS, means VGS is greater than the VTH. If we increases like that, then more and more number of electron will come into the channel, channel and it will behave as a conductor. Now we apply the VDS. Now we apply the VDS on a small amount of the VDS. If we apply, then it will start the conduct. How I am telling like that. Now the channel is formed. Okay, actually, if we apply the voltage VGS greater than the VTH, then more and more number of electrons come already into the channel. Now, if we apply the so this is the gate terminal. Okay, in the gate terminal I apply the positive voltage. Okay, and this is the source terminal and this is the drain terminal. Now if we apply the positive voltage now on the drain terminal, see, and this is the source terminal, this is the drain terminal. Now if we apply the positive voltage, so due to that there is a electric field is there. No, the channel is created. So channel is created now. Our electron, this is the negative terminal, means this is the electron, this is the electron, this is the electron. Due to this electric field, the electron will go like that, electron will go like that, electron will go like that, electron will go like that. Okay, electron will go like that. Now if we apply the small amount of the VDS, the VDS value, it will start the conduct, and that current is called, the current is not equal to 0, and we will get the sum current. This is the complete analysis of the enhancement atmosphere. Okay, now if we apply the small amount of the VDS value, then we will get the current id will equal to non equal to 0. So if we apply more and more VGS compared to the VTH, that is called the strong inversion. A strong inversion. Inversion means channel has inverted, means more number of electron will come across the channel. So this is the thing. If I draw the output waveform, or that is the output characteristic, this is the important thing I am telling. Output characteristics means this is the ID current and this is the output characteristic, that is the VDS. Okay, initially like that, and after that the current will be the saturated. How I am telling this thing, I think in the first part I explained. Oh, okay, again I am explaining. This is the VDS set and this is the saturation region. And now suppose if we apply the VGS as equal to the 3 volt, no problem. Okay, see, so this is the linear region and this is the saturation region. Current will be saturated. If the value of the VDS is small and small, if the value of the VDS is small, in that case the MOSFET will be in the linear region. Okay, the linear region, this region, into the linear region. But if the VDS is increasing and increasing, I am showing here the just the cross section of the MOSFET. Cross section of the MOSFET. I already explained in the first part. This is the source and this is the drain and this is the channel. Okay, I told like that. If we apply the small value of the VDS, no problem. There is a, or this is the channel. Sorry, so this is the body. Okay, this is the body. Due to this body, I told if we apply the positive voltage, there is a internal diode is there. There is a internal diode is there between. So this internally diode is there between the body and the drain, या body या channel, you can tell like that. Okay, body means the substrate and channel, there is a internal diode is there. So if we apply the VDS voltage more, in that case, if we apply the small amount of VDS value firstly, in that case there is a penetration of the depletion layer which happen. Actually here the depletion layer will be formed like that. Depletion layer will be formed like that. The depletion layer will form. Due to this depletion layer, means this will be depletion layer will be formed like that. The depletion layer will be formed. Actually, if we apply the positive voltage and the drain terminal, so it will be connected at the actually n type. So n terminal is connected to the positive voltage and np terminal is connected to the negative, means ground. So it will be in the reverse bias. Means if we apply the VDS voltage more and more, yeah, something I am applying VDS, then we are increasing the reverse bias. Due to reverse bias, the penetration of the depletion layer will happen across the channel. So if we apply the VDS is less, so like that. Due to that, the penetration happen. If we increase the VDS, if we increase the VDS, so like the channel depleted like that, channel depleted like that. The channel, if we increase more VDS, the channel depleted like that. Now I am telling the what is the VDS at the value of the VDS, that is called the VDS set. The VDS set at the value of the VDS at which the complete channel is depleted at the drain side only. This voltage is called the saturated voltage. Okay, this is called the saturated voltage. Okay, saturated voltage. If we increase more and more VDS, the value of the VDS, listen, the value of VDS at which the complete channel is depleted at drain side only, this voltage is called the saturated voltage, and after that the current will also saturated. Why this thing happen? Okay, I'm telling, suppose this is a channel. Okay, this is a channel. Okay, and channel is depleted up to that. So due to that, the negative, so the positive ion came. Actually channel is depleted, means in the depleted area high amount of electric field will be created. High amount of electric field, this is the region, this is the complete depleted region. High amount of the electric field will be created. Due to this electric field, on the electron, high amount of force will create. Due to this electric field, due to this electric field, a high force will become, a high force will be act on the electron. Due to this force, the velocity of the electron, velocity saturation, you can tell the velocity of electron saturated. You know na one expression, vd is equal to mu into E. The velocity of the electron saturated. If the velocity of the electron will if the electric field is more and more, if the velocity is saturated, in that case, after that the current will also saturated. Again I am telling, if the channel is depleted, high amount of electric field develop. Due to this high amount of high force will act on the electron. High force will act on the electron. Due to that, the velocity of the electron will be saturated. If velocity will saturated, then the ID current will also saturated. That thing I am telling. And if we increase the VDS is more, something more, okay, that condition is called the pinch up condition. Pinch up, actually previously I explained the pinch up voltage. Here I am explaining the pinch up condition, So what is the pinch up condition is there? If we apply the more and more voltage on the drain terminal, then the channel is depleted like that. If channel is depleted like that, then that situation will tell this is the pinch up condition happens. This is the pinch up condition happens. If we apply the VDS, if we increase the VDS more and more, in that case the channel is going to be depleted. If we increase the voltage VDS like that above the VD set, yeah, on the VD set, above the VD set, then this condition is known as the pinch up condition, and the condition is VDS is greater than VGS minus VTH. VGS is minus VTH is nothing but this is our drive voltage. Our drive voltage. I think in this part also, and why the name is the MOSFET. So MOS name is due to the metal oxide semiconductor. So this is the semiconductor, this is the oxide, this is the metal. Why does the field effect transistor? Because of that, if we apply the positive voltage on the drain terminal, on the drain terminal, then a electric field will be set up. If we apply the positive voltage, just I am drawing in the a small part. So this is the n plus and n plus region. Okay, if we apply the positive voltage, and this is the source and this is the drain. If we apply the positive there is a so there will be a This is the positive voltage in the gate terminal. So there will be electric field will be set up from the drain to source. Okay, that's why I am telling this is the field effect. Due to this electric field is the responsible to attract the electron from source to drain. From source to this is negative terminal. No? This is the electron. This way electron. This way electron. I explain this thing. So due to this electric field is responsible to attract the electron from source to drain. That's why name is the field effect transistor. Okay, and electron are able to attract from the drain terminal, will attract and will go, and the current will flow in the opposite direction of the electron. Current will flow in the opposite direction of the electron. I think you know that thing already. So that's why the name is the field effect transistor. So pinch off condition, finally I am doing the output characteristics, and the remaining thing I will discuss in the next video. Otherwise the video will be very lengthy. Okay, this is the id. So I told like that, if we apply the vds as a small, firstly that is the linear region, and this is the saturation region. All the region I will discuss in the next part. Okay, I will write the current equation also. So if we apply this, vd sat is different for the different vgs. Suppose like that, suppose this is the vgs1, vgs2 is increasing, then vgs3 is more increasing, then vgs1 and 2. Okay, so this region is called the saturation region. This region is called the saturation region, and this region is called the linear region. Okay, this region is called, this completely region is the linear region. Okay, and this region is the cutoff region. I hope you understand this all region, cutoff region. The cutoff region, in cutoff region the current will be zero. When the VGS will be zero, when we, so the thing I told in the video, if the VGS will be zero and we are applying any one of the VDS, the current will be always zero. That is the cutoff region, the saturation region, linear region. In the next part I will discuss the equation of the current equation. Thank you.